Good morning, everyone. Today we're going to review what we have discussed so far and hopefully advance to our lessons. The objective is for us to finish the different types of data structures, namely vectors, lists, data frames, arrays, and matrices. Okay, that will be our focus for this part of the lesson. And I think we'll be able to finish this by Friday. Okay, so by way of quick review, we said that the most simple type of data structures are vectors. Vectors contain the same type of data. It can be an object containing all numericals or all integers, all character data, all logical data, etc. So a collection of this becomes one or more becomes a vector. On the other hand, if you have a combination of several items, then several different types, then it's called already a list. Now, may I ask you, class, if we have this code that we use, kindly check if you have this my vector, then you have this list. Kindly chat, please, if yes. If not, then I'm going to share this. So we're now looking at the second. This is just a review of the second type of data structure, which is a list. Kindly chat, please. We have this. Okay, no, all right. So let me just share this. Okay, I think you have there the structure type number 2, right? But anyway, I'll just share this in case you don't have it. I'll put it in the chat box. Okay, and then you may just copy it. So we're looking at structure number 2. So a list is different from a vector. Okay, if I, for example, create an object called my vector, and let's remove this. Let's see what happens. If I remove here the list function, take note that it automatically gives us an X here. Why is that? Let me see. Comma, C, comma 1, 2, 3. Okay, so what's wrong here? 1, 2. How many open parentheses left? 1, 2, 3, 1, 2. Okay. All right. Anyway, let's run this without the list. So you have 1, 2. 1 and 2 are numerical values. This is integer. This is a vector of character vectors. Monday, Tuesday, Wednesday, Thursday. Then comma again. This is character. Hello. Comma. This is logical. If we run this, okay, it will generate an error term. Okay. Unexpected. Why is that? What's wrong here? This is not supposed to be the error. My vector. Did I make a mistake here as far as the commas are concerned? 3L. So this is our vector of characters, comma, hello, comma, and then false. Unexpected, comma, why? Can you help me decipher, class? Okay. Okay, we have to put a C here. Let's see. Combine there, okay. All right, that's the mistake. I didn't put the C here. So we're combining this one, 1, 2, integer 3, and then this is a vector of characters, Monday up to Friday, and then comma, hello, and false. If we try to run this to create an object called my vector, which consists of different data types, it will generate, okay, what it did was to, what happened, class? It did generate an object, right? But what did it do? let's see in our object. Okay, values. It coerced all the values into a character, right? But we don't want that. What we want is 1, 2 to be numerical, 3 to be an integer. Okay. So when we created this object, we were combining this. There was coercion that happened. It coerced all the elements here into the highest level of data, which is the character. And we don't want that. What I want is a combination of data that's numeric, that's integer, that's logical, etc. So we have to use the function list. Okay, the list function will allow us to create an object that has a combination of different data types. If you run this, okay. So now we have we have this object. Okay, it printed my vector, and if you take a look at our environment, you notice that here is data. Okay, and if I, for example, generate here a 1 to 3. Okay, just to distinguish a, you know this a is integer 1 to 3, right? And it will be under values. On the other hand, the object my vector, which is a list of 6, will be under data. So if you have a data frame and a list, it will fall under data. If you have a vector, it will fall under values. For example, I'm going to create this object B, and it's just number 3. Okay, enter. So here, B is a vector of one element. C, that's you see is true. Okay, so C is an object containing true, which is logical, and it's just one. Okay, it's one type. Then it will fall under values. It's a vector of logical. If I include, for example, if I make this C of true and T and F, this is still a vector because it contains the same elements. Let's run this. Let me call this D. So I'm creating this object called D, and it contains true, T, and F, and these are acceptable terms for true or false. Okay, so this is a vector containing true, and false, and it will fall under values. Run. Okay, can you see this? This is a logical vector. True, false. Okay, so let me pause for a while. Is it clear, class, that the difference between a list and a vector? Kindly chat, please, if it's clear. Thank you, Matthew. How about the rest? Thank you. Good. I hope I get 100% participation from the class. We are 25 all in all, 26. Okay, so hopefully I have 20 plus chats. Okay, although still lack more responses, I hope everybody responds to us. Okay, so I hope it's clear that a list is different from a vector. A list can contain different data types. Okay, so we have here, if I go to the environment and search for this object, this one, my vector, if I click this, it will identify this one. Okay, my vector, and then this is numeric, integer, character, logical. Or if I click this, it will bring us here. Okay, so you have here a list of 6, double, integer, character, logical. Okay, we can see here that a list is a structure in R that contains combinations of different types of data. Okay, a list can contain also another list. Okay, so for example, let me just share this with you. Just this one. Control C. Let me chat this. You may wish to copy that. So we have here an object called L1. It's also a list, and it includes this. This object is my vector. It's also a list, right? So a list can contain a list, can contain a vector, okay, vectors and lists. So let's run this. Okay, so we now have, okay, let's take a look at this here, a list of 4. I'll click this. So it contains the list L1 contains a list of 6, a numerical vector, a character vector, and a logical vector. Okay, so ito siya, no? It contains a list of 6, a numerical, character, and logical vector. The list of 6 contains a numerical, integer, character, and logical. Okay, so okay, okay, so a list can contain a list also. Let me just close this and close this. Okay, I hope that's clear. Okay, then a list, as I mentioned, can also contain a function here. Let me share this with you. Right, so a list can contain, here we have a vector 1 to 5 integers, a vector category character, and then C here is a function of x, which is x times sine x. Okay, we're going to learn more about functions in the future. So let's run this. Okay, and what are the elements here? Here you have a vector. This is a, let me see here, my list here. Okay, so this is an integer vector, 1, 2, 3, 4, 5. Okay, so this is my list. It's a list of 3. It's a character. And then you have here a function. Okay. All right. Function x times sine of x. We're going to deal with functions in the future. All right. Now, the object MyList contains 3 things, right? What do this contain? It contains this vector, integer vector, this character vector, and this function. Now their lengths are different. Okay, if you recall, you can get the length of a vector. So let's see. We have a vector A, 1 to 5. Okay, this is A. Let's see if we can get, but A is from, okay, the A that we have is the A that we generated a while ago. Here, 1, 2, 3. So if we want to get the A here in the MyList, how should we do it, class? If I want to access this, what do I do? If I want to get the length of this vector A, which is found in the list, MyList, what code should we write? Anyone, please? Do you understand the question? We have this object, MyList, right? If we take a look at what's inside here, it has A, B, and C. Okay, if I want to get the length of the vector A that comes with MyList, what code do I run? How do I get the length of this object A? This one. It's found in MyList. Waiting for your answers, class. Structure. Matthew, can you chat? Matthew, please share your answer to everyone. Can you chat the the code itself. Okay, structure of what? Okay, structure, right. Nag-suggest si ano si okay, that let's see first the answer of Matthew and then we go to the answer of Margot. If we take the structure of A, okay, structure of A. Remember, class, that A, there's an object A here. Okay, it's a vector. So if we get the structure of A, it will just give us that this is an integer from 1 to 3. Okay, so A will only recognize this object that's listed in the environment. Okay, it will not recognize the A that's found in my list. And there's this, Margot, could you kindly explain your answer, please? May unmute yourself, please?
So explain.
Yeah.
So basically, because A is a variable found under my list,
Okay.
you have to link A to my list
Okay.
to
So
find the link to find its
okay,
length. Yes.
the length. Okay. Let me see. Let's copy this. All right. It's length of. So Margot is suggesting that we access this object MyList, and under that, under MyList, as shown here, is your object A. So let's see. There. So thank you, Margot. Thank you, Matthew, also for suggesting an answer. So this is the correct code if you want to get the length of A. Okay, thank you, Margot. Thank you, Matthew. Okay, so as I was saying here, okay, my list contains 3 objects, A, B, C. Their lengths are different. A has a length of 5, B has a length of 1, and C is a function. So it doesn't really have a length technically. It has a length of 1. So if I get the length, okay, length of my list, okay, it will give us 3. Okay, so technically, so this is wrong. It has a length of 3 actually. It has a length of 3 because there are 3 objects there, A, B, and C. So if we, okay, let me share these functions with you, these codes with you, so that you can work on that. Okay, here we're getting the type of my list, this object my list. If we run this, okay, it gives us that my list is it's a list. And we have run this length of my list is 3. And we can subset my list. The first element here is your A, right? And A is 1, 2, 3, 4, 5. Recall this is to subset. Okay, my list 1. And notice you only put 1 number here. Okay, because my list is not a rectangular data. So you don't have rows and columns. You have only one. You have only one row. Okay, or one column. Depends on how you write it. So my list 1 is your A. If I type my list 2, it will give us B. Okay, if I type my list 3, it will give us C. So can we do math on this? Let me go back here. My list is the first one is A, right? 1 to 5. Can I add my list A plus 1? Can we add 1 to that? Okay, error. Okay, we cannot add 1 even if my list 1 is a vector of A. Okay. Unlike, okay, let me illustrate this. So let's create an object called D, and D is an integer vector from 1 to 5. Okay, so we now have E here, E, integer 1 to 5. And then if I add 1 to E, okay, it will perform this. It will perform the vector, and then it added 1 to each of the elements of 1 to 5. Okay, unlike this one, although we're subsetting, it does not allow for us to access the A here and then add one. Okay, so these are some quirks as far as the list function is concerned. Okay, so this one we skipped. We already did this before. Okay, the set.seed and the rnorm. Okay, we had this example before, so let's skip that. Okay, and then we go to the third data type. Okay, before we proceed, are there any questions? May I have your response, class? Is the discussion of the list object, list data frame, data structure clear so far? Okay, thank you. Thank you. Thank you so much. Appreciate the feedback. Okay, good. Okay, we go to the third data structure type, which is for us the most important one. In the course of this subject, we will be focusing on data frames. So could you kindly check if I gave you these notes? Okay, check please yung file nyo. I think you have this, right? Structure type number 3, data frames. Kindly check please if you have. Yes, okay, good. Thank you. All right. Okay, so what are data frames? It's a tabular or two-dimensional array-like structure. Okay, when you say tabular, you have rows and columns. Unlike the list, you don't have rows and columns there. It's just one-dimensional data. For data frames, it's a two-dimensional array-like structure. Each column contains the values of one variable, and each row contains one set of values from each column. So let me just annotate this a bit. Okay, so what are the requirements for a for a data to be considered a data frame? Okay, first, the column names should be non-empty. So therefore, you should have, for example, you have a data where the column name is Y1, whatever that is, Y2, and Y3. Sorry, X1, you call it X1, X2, and X3. So here you have 3 columns. And the columns are named accordingly, X1, X2, X3. And then we have here observations, 1, 2, 3, say it's up to 100 observations. Okay, so this structure is what we call a data frame. There are other special types of data frames. For example, we have what we call a table, which I think you met already when we looked at the. If you recall, what data were we looking at? Yes? That exposed us or introduced us to the table object. If you recall that, class, what data were we using? Yeah, thank you, Matthew. It was the diamonds data set from ggplot2. And we were told that that's a table. So that's a table data frame. Okay, a special type of table. All right, so these are the attributes of a data frame. The column name should be non-empty. There should be a name to the column. The row name should be unique, if ever. Sometimes you don't have names for the rows. Rather, what you have are the index. So the index become the names of the rows. For example, row 1, row 2, row 3, row 4. Okay, so let's do that first. Okay, okay, so why don't we get the let's first. Okay, how do we access? Question: how do we access the diamonds data set? Can anybody tell me how to do that? The diamonds data set. What do we need to do first? Class, what do we need to do first? Where is the diamonds data set coming from? Is it from base R? Because if it's from base R, then we can already access that automatically. You recall, class? From what package is diamonds coming from? Anyone? Yeah, thank you, Margot. Yeah, it's from ggplot2. So remember, what do? We have to first load ggplot2. And so we can type library ggplot2 or go here to packages Okay. Since we have already installed this, we don't need to install, just type GG. Okay, and then we have here ggplot2. And then you notice it's not yet loaded because it's not yet clicked here. It's not yet checked. So once I check this, it's the same as typing library. I didn't type this class. When I click ggplot2, automatically it typed here in the console library ggplot. Okay, so now that we have loaded ggplot2, we can access now, let's say data and then diamonds. There, data diamonds, enter, and initially it will appear here in the values promise. I don't know why R uses that word. And then let's view it, view. Okay, view diamonds. Okay. And even before I finish running this, it already start here. I think the promise there, it's just temporarily loading your data. Okay, temporarily loading your data until it finally fully loads it, and then it becomes part of data. All right, so let's run this. So we now have this. All right, so we looked at this, and then let's take a look at the structure of diamonds. Okay, so we have this. Okay, let me first remove the annotate and then clear the drawings because it's confusing. Okay, so we have here in the console the structure diamonds. It's a table. A table is a special type of data frame, but nevertheless, it's still called a table data frame. So here it is table data frame or table or data frame. So different names for it. S3 is a type of object. Okay, it's similar to a data frame. All right, we looked at this before. So this is a perfect example of a data frame. Here you have column names. Okay, each column has a name. Each row is unique in itself. It also has a unique name. The name here are the row indices, 1, 2, 3 until 53, 940. Okay, 53, 940. Let's take a look at the other attributes of a data frame. We have now number 3. The data can be numeric, factor, character, or any other thing. So we have here, this is a character. In fact, this is a factor because it's used for classification. Also this one, color, it's also a classifier. How do we know that? Here, it was already, okay. How should I say it? It was already, there's a term for that. Converted from a character to a factor. So cut, and then also color. They are ordinal factors. And then is there another one? Okay, 2 character variables, 1 integer, the rest are numeric. So here you have different data types. Okay, we can see here ordinal. And one thing about a factor is that when we summarize this, it will give us the frequency. So summary of diamonds. Unlike character, okay, where it will just tell us the type, that it's a character. If it's a factor, it will give us a frequency, a tabulation. Okay, so let's look at this carat. We have the 6-number summary, the minimum, maximum, first quartile, third quartile, and the mean. Okay, here, cut is a ordinal factor. You can see here the frequency count. Fair, good, very good, premium, ideal. If this was only a character variable, then it would not give us this. It would only tell us that it's a character, okay, the type of and the class. But since this is a factor, gave us a frequency count of the distribution of the factors. Remember, factors are used as classifiers. Okay, so classify fair, good, very good, premium, and ideal, etc. Okay, also color. Okay, it also gave us the frequency distribution, the count. Okay, all right. So these are the qualities, attributes of a data frame. And we can see that a good example of that is our diamonds data set. Okay, this one, each column should contain the same number of data items. Okay, that's very important also. Each column should have 53,940 entries. Some may be missing, some may have zero values or NA values, but it's not, it, remember the list, the list object where you have A has a length of 5, B has a length of 3, C has a length of 1. Okay, a data frame should have the same number of observations per row. Okay, so if you have, I mean, per column. So Z should have 53,940 observations, etc. So all of this are the qualifications, are the attributes of a data frame. Okay, clear so far, class? Kindly chat, please, if the explanation about what a data frame is clear so far. Okay, thank you. Appreciate your feedback. Thank you so much. Okay, let's wait for the others' feedback. Okay, how about the others? Feedback, please. Okay. All right. Thank you. Thank you, class, for your feedback. Although I hope again that everybody gives their feedback or comments. Okay, kindly check again your file if you have this example one. Chat, please, if you have that, so that I can share it with you if you don't have it. Do you have this code chunk, example one? Okay, no. All right, so let me share this. I think I gave you only example two. Okay, so let me share with you example one so that we can work on that. Just copy that in the interest of time. Okay, so quickly, let's take a look at this code chunk. We're creating this object NSB and consists of a vector of a numeric vector. S consists of a character vector, 3 elements, and B consists of, and I mean B consists of, it's a vector consisting of 3 logical elements. Okay, so if we run this, we'll be generating 3 objects, NSB. Okay, let's run that. And you can see here that it prints out the object N, S, and B because of the parentheses that we place there, right? And if you take a look at our environment, it should be here, NS, and then alphabetical B. All right. Now, if we're going to create a data frame out of this, we can use this object, just like list, to generate a list. To generate a data frame, we use data. Okay, so here we have an object df, data frame, and then we're concatenating n, s, and b. Okay, so if we run this, let's print and then let's get the class. Control Enter. Right? So the class is data frame, and this one is the object itself. All right, so you have here n, which is double, which means it is numeric, s is character, and b is logical. All right, class is data frame, as expected. This one, it's a data frame. Okay, let's try to get the length. When you get the length of a data frame, what does it give us? It gives us the number of variables, the columns. Okay, however, for dimension df, what will this give us? Dimension df gives us the number of rows and the number of columns. So this is row by column. Okay. All right. Unlike Okay, just to distinguish it with between a vector. Okay, let's take a look at this. If I get the length of A, I know that this will be 3, right? Okay, 3. But if I get the dimension of A, okay, it's null. Okay, a vector does not have a dimension. Okay, because a dimension is used for number of rows and number of columns. Even the list. Okay, let's get the dimension of this object, MyList. Okay, dimension of MyList. Okay, it's also null. The dimension is specifically used for. Okay, it's specifically used for your data frame. Okay, any questions so far, class? Okay, let me change this. No questions? Okay, good. Now let's go to example number 2. I know you have this, but we will change it a bit. Okay, do you have this code chunk, class? Are you sure, Mariel? Walang example 2, class?
Sir, para po yun din sa question, sorry.
Sorry.
Abo.
Okay. Thank you, Mariel. Sorry. Okay, do you have this code chunk, example 2? Kindly chat, please. Do you have this? Yes, I know you have it, no? This one, example 2. However, we made some changes here. So, okay, I know originally, we have here, okay, walang round to, no? Okay, wala din to. So let me just go back to the original. Okay. This one. And then, okay. All right. So I think this is the original one. So let's take a look at this. We are generating an object, employee.data. Okay, and then we put parentheses here so that it will print automatically the object. Okay, and then you know by now that using this function data.frame will allow us to generate a data frame. So what's included here? Number one, we have this employee underscore ID. And then we're using this run if. So what does the run if function give us? Let's just, it's a good practice always to seek the help functionality of R. If you meet a particular function that you're not aware, it's new to you, use the help function. It's very helpful. So run if, let's use the help function. So it's coming from the stats package. It's for a uniform distribution. Okay, this one, yung run if. Unlike the R norm, okay, the R norm generates a normally distributed random numbers. This one generates a uniform distribution. Okay, so you also have different types: done if, fun if, qun if, and run if. We're using run if. Okay, this is the function for a uniform distribution. F of x is equal to 1 over maximum minus minimum. So what you do in order to convert, let's say, a data into a uniform distribution is, okay, let me just illustrate that very quickly. So suppose you have, okay, you have a vector z is equal to let me see. Walang run dito sa R, no? Ang run pala sa Excel, no? Okay, anyway, I'll just generate this, say 1 up to 50. So this is our object z, it's 1 up to 50. So how do we convert this into a uniform distribution? To convert this into a uniform distribution, we look at each value. So from 1 up to 50, and then convert So we know that the maximum of Z, of course, maximum of Z is 50, and the minimum of Z is minimum of Z is a 1. Okay. So to convert it into a normal distribution, we just use this formula. F of x is equal to 1 over max minus min. Okay. Anyway, what I want here is to do the function run if. Okay, may question ba? Okay. The function run if generates random deviates. Okay, just like R norm, just like what was the other one that we used? R norm, tapos ano pa yung isa? Sample, ano pa ba? I think we also used another one. Wala na ba? Okay, run if also generates random numbers. Okay, let's have an example here. Okay, ito, class. Let's copy this. Control C, run if. So we're creating an object here called U. Oops, sorry. Run if U 20 random numbers. Control enter, and then let's print this U. All right. What do you have, class? What do you have? Did we get the same answers, class? Of course, I expect you to say no because these are random numbers, and we did not use the set.seed. Okay, but what's the attribute? What's the behavior of this data? If we use the hist, if we plot this hist U, okay, you notice that okay, this is how a uniform distribution looks like. It doesn't really look like a uniform distribution, not so much because we have only a few data set. But what if we say, what if we make this 10,000? Okay, we use run if 10,000. It will give us numbers between 0 and 1. Okay, enter, and then let's get the hist of U. Okay, it will now look like more of a uniform distribution. There, di ba? Uniform na siya, no? There. Okay, so that's a uniform distribution, unlike a normal distribution, which yung bell curve natin. Okay, clear so far, class? So the run if function generates a uniform distribution. So we tried run if 20, and then when we plot the histogram, it doesn't look like a uniform distribution because of the very small sample size. But when we made it 10,000, it really looks like now more of a norm uniform distribution. Okay, so that's a run if. Now let's go back to our code. What we're going to do now is we're going to generate here employee ID run if 10 numbers, okay, and it's between 1,000 and 999. Okay, when we run this, so let's try this. Let's copy this, Control C, and then let me just sweep this, Control V. Okay, run. Okay, Neos, mute na lang kita muna, Neos, ha? Okay, so here, class, run if 10 numbers, okay, between 1,000 to 999. Okay. All right. So we will have different numbers. So because we would want to assign an ID number. The ID number is between 1,000 and 999. We want to remove the decimal place. So what we can do is first let's set that seed. Set that seed. Let's just use 1111. This is just a random number. You can use any other number for as long as we have the same numbers. So set that seed 1111, and then employee ID 10 numbers between 1,000 and 999. And then how do we remove the decimal? We can use the round function. Round, okay, round. So this is the number and then we were rounded off to 0 decimal place. Okay, the 0 here indicates that no decimal place. Then let's put a comma here to separate from the next one. Okay, so take a look at this. So what are we rounding off? This one. We're rounding off this run if function, 10 numbers. What are the numbers? Between 1000 and 999. So we want a 4-digit ID number. And then we don't want the decimal, so that's why we did round and then 0. Close. Okay. Clear so far, class? Is this clear yung employee ID natin? Kindly chat, please. Okay, good. All right. We will be able to generate the same numbers here because we're using the set.c. Okay, and then here we have employee name. Let's check how many names these are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this is okay. Okay, should be 10. Okay, and then salary between 20,000 and 500,000. So in order for us to have the same salaries, let's also round. I mean, we will have the same salaries because of the set.c. Okay, and then let's just make it 2 decimal place because that's money. Okay. All right. So we close the round function. We put the number of decimal places, then comma, and then let's take a look at this. Start date. So this is the name of the variable, start date, when the employee started with company. And then these are characters actually, right? Because of the quotes. However, we will coerce it to become a date function, a data, as that date, and then concatenate all of this. So these are 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then we can put here strings as factors. Okay, strings as factors is equal to false. Okay, what will this do? There are some character variables here, like this one, employee name. We are imposing that this one should not be considered as factors. If we have, for example, residence. Okay, let's put here. Let's add here. Residence is equal to, say, as that factor. Okay, as that factor, and then C. Okay, invento lang tayo Manila. Let's make it 10. No? 2, another Manila, 3. Oops, Manila. Okay, and then let's say QC. Say Las Piñas. Las Piñas. Ilan na yan? 1, 2, 3, 4, 5, 6. Say, let's add another QC. 7. Another, say, another 30. How many do we have? 1, 2, 3, 4, 5, 6, 7. 3 more, comma, and then Manila again. And then, okay, San Juan, Manila cities. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9. One more. Let's see. Ano pa ba? Valenzuela. Valenzuela. Right? So, see, as a factor. So we have to close. Then here, comma here. May mali pa ba? Comma here. May A ako dito. No? Okay. Salary. Then comma. Okay. Okay. So we added salary. we added reference and then as that factor. Okay. So this is a string character to, no? Pero here, it's we place here as that factor, and then here strings as factors false, which means others like this one should not be considered as a factor, right? Okay, so let's run this. Okay, let's remove this first. Mamaya na natin i-run to. Ito lang muna, no? Okay, let's see. Control Enter. Okay, so let's take a look at our data frame. Okay, this is our data frame. So employee ID, employee name, salary, residence, start date. 1, 2, 3, 4, 5. Okay, so let's check class. And we expect this to be data frame. Okay, data frame siya. Okay, and then let's take a look at the structure. All right, so if you take a look at this one, okay, di ba? Ito, no? Yan. Employee ID is numeric. Employee name is character. Salary is numeric. Residence is factor with 6 levels. Start date is a date format. If you take a look at run the summary function. Yan. Okay, notice employee name being a character, linagay lang yung class niya, tsaka yung mode. Pero si residence, okay, it gave us the frequency count. Las Piñas is 1, Makati is 2, Manila is 3, etc. Okay? Although, ito nakakatawa kasi si date siya, di ba? So, parang binibigay pa rin sa atin yung minimum first quartile, second quartile, etc. Although this doesn't mean anything. Kasi may average pa yung date. So what happened here was the date was converted into a number, tapos kinuha niya yung average. Although, alam natin na date siya, di ba? Take a look at this one, di ba? Yung sa structure, let's go back here. Anyway, so let me run this again, itong structure. So structure ni date, it's a date. It's a date format. Okay, so let me pause for a while. Any questions so far, class? Clear ba so far yung what we did? Okay, good. Thank you. Let's wait for the others' response. Okay. Thank you. Thank you for your responses. Okay, so we now have this. Wait. Okay, let's take a look now at this data, this code chunk. Do you have this? Example 3. You have this example 3. Let me see. No. Okay. Sige, let me share this with you. Okay. This is quite a long, okay, just to save on time, class. Okay, it's a long, there are several code chunks here. So that we save on time, kindly copy it. Although, given the, if you have more time, I would let you be the one to write it because it helps if you're the one doing this. Okay, so let's take a look at this. Okay, we have this object ID. It's from 1 to 200. And then we're creating this object called group, which is concatenating. The rep function is repeat function. So when we use this rep, what we're saying here is repeat this character, okay, this string of characters vehicle 100 times, comma, and then repeat also drug, the word drug 100 times. So all in all, this object will create an object called group, and it's a vector. It's a vector of 200 observations with names vehicle and drug. So let's see this first. Control C and then Control V. So was I able to copy it? What happened here? And okay, this one. Anyway, I'll just run it from here. Okay, so if we take a look at this group, it's a character consisting of 200. Okay, let's get the head of group. So this is the first 6, and let's get the last 6. Okay, so because we named, we generated this object called group consisting of 100 vehicles and 100 drives. All right, let's also take a look at the response. And here is where the set.seed will come. Let's just use another set.seed 1, 2, 3, 4. So we're creating this random numbers, 100 random numbers with mean 25, standard deviation equal to 5. And another one, 100, mean 23, standard deviation is equal to 5. Okay. And then here, we're creating this object, my data, which is a data frame. Okay. Take a look at this. It consists of ID, group, and response. So the ID, which is this one, will be named patient. The group will be named treatment, and the small R response will be named as capital R. Of course, this is quite redundant because we could just have used here patient, and here treatment, and here response. But this was meant to show you that we can change the names. Okay, here we're saying that let patient be equal to ID, let treatment be equal to group, and let response be equal to capital R be equal to our small response. Okay, so let's run this. Okay, no, sorry, not yet. We haven't run the other. So let's run everything. Let's run the whole code chunk. Okay, and then we have now this object called my data, which consists of 200 observations. Okay, so it just presents to us the first 10 rows. And then we have here the response time. Response time as far as vehicle is concerned, and response time as far as drug is concerned. Right. So I think this is a data where they were measuring the response time in terms of vehicle, maybe, I'm not so sure. And then response time as far as a particular drug is concerned. All right. So this is a data frame. We have here the names of the columns, patient. The name of the column happens to be, okay, let's view this, view my letter D. There, it appears, no, my data, because we have already created this object. Run. Okay, we have a variable here called patient. This is patient ID. The row name is actually this one. It's an index 1, 2, 3, 4 up to 200. So of course, these are unique names. This is a variable in itself, an ID number, then treatment, and then response. Okay, let's learn something about subsetting. Okay, so this one, okay, we know what will this generate. The first 6. Okay, this one will be the first 15. This one, the last 12. Okay, let's not run this anymore because we know that. The length of my data, you know that it should be 3 because there are 3 variables. Okay, my data has 200 observations and 3 variables. And then the dimension will be 200 by 3. Okay, so this is just a repeat of what we have discussed. The structure will give us that this is a data frame consisting of 200 observations. Then it identifies the variables that are found in that object. So you have patient, which is integer, treatment, which is character, and response, which is numeric. And then the summary, you know this already. Since patient is numerical or integer, it will still give us the 6 number summaries. Treatment will give us the class or the mode and the length, of course. And response, which is the most meaningful here, gives us the minimum, maximum, etc. Okay, I'm going over this quickly, class, because I know that you know all these things already. Okay, let's now do this. Okay, subsetting. There are different ways to subset a data, or whether it's a vector, a list, in particular, in our case, a data frame. Okay, let's first take a look at the function. Okay, this is one way, using the brackets. But another way is to use, let's just first take a look at the function subset. Let's run this. So the function subset comes from the base R, which means that we don't have to load a particular package in order to run this. So returns a subsets of vectors, matrices, data frames, which meets conditions. So you can subset whether a vector, a list, a matrix based on certain conditions. Let's take a look at the syntax. Okay, here we have an example. Okay, let's take this example first. So air quality, let's see what air quality is. It's another data set. Okay, air quality. Air quality. Let's take a look at what this data set is. So it comes from the package datasets, which is already preloaded with R. So you don't need to install this package datasets. It's already preloaded with R. Okay, so what do we call this, class? What do you call this? There's a name for this. The data about the data, or information about the data. That's called your, anybody? The blank data. So any information, any data about your data, just like this. Okay, let's take a look at this. So it gives us daily air quality measurements in New York from May to September 1973. So what are the variables contained there? So comma 1, this is all the rows, and then column 1, this is ozone. It's numeric. Column 2 is solar.r, numeric, also wind, temperature, month, numeric, and then day, which is also numeric. For me, month could be converted into factor because this is January up to December. Okay. All right. So this is about daily readings, air quality. Let's not go into the nitty-gritty details. It tells us where this came from, and then we have examples here. Okay. All right. But we're not interested in the examples for air quality. We're interested rather. Let's go back. We're interested in the subset. Okay, so we can access. By the way, what's the name of that one that we highlighted? It's called your, anybody? Letter M. Yes. Let's see. I see an answer. Yes. Thank you, Margot. You're correct. It's your metadata. Okay, it's metadata. It's your data about your data. It's your information about your data. So metadata are important because it tells us something about the data, the nature of the variables, etc. All right. So let's here we just want to get to learn about subsets. Okay. So let's access data and then air quality. All right. You see, automatically it shows us this one. Oops, sorry, I got the wrong data air. You have air passengers. You have air. Oops, air quality. Tab. Enter. So let's see if my hunch is right. I haven't really studied this promise thing. Let's give a few seconds and let's see if it will convert into the data. So it's not converting, which means it's not automatic. So let's run view, and then air. Okay. Now once I start the view and then accessing air quality again, you notice that it was already transferred to the data section, which means, okay, air quality tab here. So we can see here that it's a data frame. Okay, but notice there are NAs here, so no problem. Data frames can contain missing values. So there are missing values there. There are 6 variables all in all, 153 observations. So what we want is, let's get the names. I don't know if we discussed this already, names of air quality. So that's our object, air quality. What will this generate if we get the names of air quality? It will give us the variable names, okay? So the names function will give us the variable names of your data frame. Okay, so let's take a look at this subset. Let's copy this. So we have this object subset, and the data is air quality. Then it tells us the temperature, this one, temperature should be greater than 50. And then select, okay, select ozone and temperature. Okay, here, this tells us that only select ozone and temperature, which means that it will not include solar wind, a solar hour, wind, month, and day. Okay, let's generate an object out of this. Let's call it S1. So S1. Okay, so it will generate an object called S1. From the air quality, it will only choose temperatures that are greater than 80. So let's run this. Okay, so we now have S1 here. Okay, let's print S1. All right. So take a look at this. This is S1. Okay. So it only included ozone and temperature because we said select ozone and temperature. And if we check the temperature, everything here is greater than 80. Okay. And let's check if this is structure of S1. Okay, it's also a data frame. So depending on what we subset, the structure of a subset of a data frame may be also a data frame because it can also be just a vector. The subset of a data frame can also be a vector if we are only choosing one. But here in this case, we're choosing 2 variables, 68 observations. It only includes those temperatures that are greater than 80. Okay, so that's one way of subsetting, the use of subset, which is, I believe, more powerful than this one. Okay, let's go here. Okay, again, let me pause for a while. Okay, are we clear so far? Plus about that example, about using the function called subset. Okay. Of course, you can make use of the other examples there. Nobody's really stopping you from learning more about the power of the functionalities of a particular function. There are usually examples that are given. Okay, any questions about that function subset? Okay, thank you. Waiting for the others. Okay, I strongly urge you to learn more about that. There are several examples there as you saw. Okay, let's now go here. Now, another way to subset is what we learned before, using the brackets, the square brackets. Okay, so let's create this object called x1. Now I didn't give this, right, because I want you to write it. X1. So we're using my data, and then here, see this 1 and 2. What does this mean? This means the first row and the second column. Okay, so let's generate x1. Okay, and you can see that x1 forms part of your forms part of your values. So it's a vector only. Okay, let's take a look at, see, my data, this one. X1 is first row, second column. So it's this one. Okay. When we subsetted, when creating X1, we want to subset row 1 and column 2. So this is row 1, this is column 2, and you have vehicle. So it's only one item. It's a vector of a character, right? So this one. That's why if we check, let's see, class, let's put here class of X1. What will we have? It will give us here character. A character, which means it's a vector. Same thing here, my data 2, 3. Okay, so let's not run that anymore because we know that it will be row 2, column 3. It will give us this one. Okay, anyway, so let's run it. X2, let's call it X2. Okay, and then let's also get the class of X2. And this one will just give us one value. Second row, third column is your response time. Here, third column, second row, 26.38. That's what we expect. And the class will be numeric. Here, numeric, right? And X2 is 26.38. Okay, so take note that when we subset a data frame, my data is a data frame, right? When we subset it, it's possible for it to be a vector, okay? But we can, of course, okay, how about this class? See, this is my data, 1 up to 20, and then 2 and 3. So it subsets the first 20 rows, okay, and then it subsets second and third column. If we take a look at this, the first 20 rows, and then the second and third columns, treatment and response. Let's see what happens if this would be a vector or a data frame. We're asking for the class. All right, so where is it? X3, take a look at this. X3 is under the data, right? So this is a vector. It's a data frame. Okay. And also this one, let's make this X4. X4 is all the first 20 rows and then all the columns. Let's see, what's the class of this? Class X4. Okay, X4 and then class X4. Let's run this. X4. Okay, let's take a look at what X4 is there. So it's just the first 20 observations of with 3 columns because we're including all the 3 columns. Okay. Of course, we could have done this using the subset function. So let's do that. Let's see X. Let's create an object called X file, and let's use the subset. Okay. Now, can you generate X3? Okay. Using subset function. I'll give you 1 minute. Kindly do that. X3 is this one. X3 is only include treatment and response. First 20 observations. All right. So I'll wait for you to kindly chat, right in the chat box, your code for replicating X3 and creating an object called X5 using the subset function. Okay, waiting for your answers, class. Kindly write in the chat box, share your answer in the chat box. Waiting for your answers, class. Use a subset function. I think it's still here. Is it still here? Yeah, it's still here. And you have a pattern for this. Waiting for some answers, class. We were 25 a while ago. Ngayon, may nawala na. 20 na lang tayo. Okay, any answer, class? Use the subset function. So may pattern naman kayo dito. You have a pattern. Okay, so no answer so far. Okay, let me leave that as an assignment for you. Okay, so the next topics will be all about, it will be all about subsetting. So maybe let me copy this. Okay, and let me share it. Yeah, Matthew, you have Matthew, you have an answer card, but this will be all the values, right? What we want is only let me address Matthew's answer after I copy the code chunk. Okay, so please copy the code chunk. Wait. Similar. Okay. All right. Okay. All right. So next meeting, we're going to continue with this. And then date objects, and then a matrix. Yeah, let me also share with you the date object. Do you have this in your file, class? Do you have the date object in your file? Okay, so you can study it also. Okay, so let's take a look at Matthew. Thank you for sharing your answer. However, sabi ni Matthew dito, the code is ito, no? Okay, let's run this. So Matthew is suggesting that we have this function, okay? X5 is a subset of my data, that's correct, and select only treatment and response. However, this will generate this will generate all the 200 values. So let me run this. Okay, X5, see, it's 200 observations, right? 200 observations. What we want is only the first 20. The first 20. So think about that. We'll continue. We'll discuss that next meeting. Okay. Let me stop recording first.